Hello.
Welcome, Jochen.
Hello.
Great to have you with us. Jochen, maybe you can tell us, first of all, what do you do at Siemens?
I'm developer in the pre-development department, which is focused on industrial edge topics for the process automation.
Cool. And what are we going to learn about in the next couple of moments?
Yes, here's my agenda. First of all, I will give you an introduction about the industrial edge ecosystem. Next, I will give you an overview about different ways of communication in the process automation. This is important to understand the complexity of communication in the process automation better. And finally, I want to show you how we want to address this complexity in the industrial edge ecosystem.
Cool. So a clear roadmap here. We're going to leave the stage to you. And if you do need anything, feel free to let me know. All right?
Okay.
You got this.
Thanks.
Go for it.
Okay, let's start with the introduction of the industrial edge ecosystem. Here you can see a simplified overview of the industrial edge ecosystem. I'm going to explain the components of the ecosystem, the industrial edge marketplace, the hub, the industrial edge management system, and the devices on the next slides. To track where we are, you will find a small picture of this overview in the upper right corner of this next slides. Let's start at the top of this view with the industrial edge marketplace. The industrial edge marketplace is the app store where you can buy the applications you are interested in. But you can also earn money by selling your own applications in the marketplace. This is possible because the industrial edge marketplace is open for all vendors. The industrial edge hub is a service which is running in the cloud. Here you can manage your applications, your licenses, and your industrial edge management systems. But what is an industrial edge management system? The industrial edge management system is an on-premise running service. It could be installed on a physical device locally on-premise or on the virtual machine, which is hosted by the customer. Also, a cloud-based managed service is currently in development. The industrial edge management system is needed to manage your industrial edge devices. And you can decide which application is running on which industrial edge device. This is the final deploying step. Some applications are providing a common configuration API, which could be also managed by the industrial edge management system. And of course, you can perform updates and plan the updates of the applications which are executed on the industrial edge devices. Very slow, I believe that. Updates of the devices. Yeah, of course, sorry for that. So also the industrial edge devices have an operating runtime or just firmware which has to be updated sometimes. And last but not least, you can handle the backups of the industrial edge devices, or also can check the status and health of the devices and the running applications. So let's have a detailed look to the industrial edge devices now. The industrial edge devices are normally a physical device. Siemens is providing a wide range of industrial edge devices based on the SIMATIC IPC platform to address all the various needs of the customers and applications. In addition to the IPC family, also industrial edge devices based on HMI panels are available, and many more devices are currently in development. The applications you can buy in the industrial edge marketplace are executed on the industrial edge devices. And now the important information. The industrial edge devices are the only devices of the ecosystem which has physical access to the plant infrastructure and field devices. And therefore, the second network interface of the industrial edge device is used. So, an Ethernet-based communication to the process automation is supported only. But how does the process automation looks like? Here's a simplified overview. Of course, Ethernet-based communication like Profinet is one existing way to communicate within an automation system. But there are many, many more. Here you can see a simplified architecture of the different communication paths down to the field devices. The most devices within the process automation are still using HART or Profibus communication. So these are totally different communication protocols and also physics. HART, for example, is a digital communication based on a 4 to 20 milliamp current loop with a very slow data rate of 1.2 kilobytes per second. Profibus PA has its own two-wire physics to communicate and power the field devices in the plant. The protocol is totally different in comparison to Profinet and HART. Last but not least, there are many, many more protocols available in the process automation system. The industrial edge ecosystem could be attached or connected to this existing infrastructure, as you can see on this slide. The question is how to manage all these communication protocols in the industrial edge. So let's transform this graph to the architecture picture of the industrial edge ecosystem as I described in the beginning of this presentation. As mentioned before, only the industrial edge devices has physical access to the plant infrastructure and field devices. So let's have a detailed look to the internal software architecture of an industrial edge device. This looks like this. So what you can see in the south are the connectors. The connectors are a special kind of an industrial edge application, and they are responsible to communicate with the field devices with one specific communication protocol. And so they are able to get the data out from the field devices and provide this information to the applications in the north. And the applications in the north are doing any cool stuff based on this information or parameter values which are provided by the connectors. So for example, create dashboards, perform predictive maintenance, provide the data in an OPC server, or just push them to any further application running in the cloud. As mentioned, there are specialized connectors for each communication protocol. And here's a short list of already available connectors. And many more are currently in development. Looks good, doesn't it? Yes, of course, but what we can do, we can further improve the connectivity in the industrial edge, because what is missing are connectors for field-level communication protocols like Profibus and HART. And why is this so important? Why can't we use an S7 connector, for example, to get the data out of the infrastructure? The answer is it depends on the use case. Because if you use an S7 connector, you are able to get the data out from a controller like an S7 for 110, for example, but you can only read the data points which are already configured. If you want to get more information and more data from the field devices, you have to change the application or the controller's program first, which is an additional effort. In the worst case, your controller is too small to provide all the data you are interested in. To avoid the memory limitation of the controller, you can perform a direct access to the field devices routed by the controller. But by using this path, you are limited by the throughput of the controller. Depending on the number of data points you are interested in, the update cycle of your data points can increase to hours. On the graphic, it looks quite simple to communicate directly with the field devices. But this is not as easy as it looks like. As you can see, it's not possible to communicate with the HART device directly via the Ethernet interface of the industrial edge device. Here, in this example, the HART device is connected to a communication module of the ET200, which is a Profinet device. And as a result, a Profinet connector is required on an industrial edge device. If you want to communicate with a Profibus PA device, which is connected to a compact field unit, the communication path looks quite the same. However, you can imagine that the communication with a Profibus PA device, which is connected to a compact field unit, is totally different in comparison with the communication of a HART device connected to an ET200. In any case, you must be able to establish the communication with the Profinet devices without interrupting the communication with the controller, which would lead in any disturbance of the running automation process. And we don't want to change the controller's program. In the connector's point of view, you must be able to handle the communication topology down to the field devices and reuse the communication layer, which are the same, to address this complexity. On this topic, we are currently working and call it Cascaded Connectors. But what is in Cascaded Connectors? I tried to show it with a simplified example. We have an industrial edge device which is communicating via Profinet with a compact field unit to get the data out from the Profibus PA devices, which are connected to the compact field unit. Each connector of this layer is handling one specific communication step down to the field devices. This is comparable to the OC model. If you want to communicate with a HART device which is connected to an ET200, the running connectors on the industrial edge device could look like this. Please keep in mind that the concept of cascaded connectors is just an idea for now, but it could be one solution to address the complexity of connectivity without the industrial edge. Sorry. But to achieve this architecture of cascaded connectors, we have to change the API which is used by the connectors. The new API is based on gRPC, which is an open source, high performance technology for microservices. Every connector on the industrial edge will provide the same API for configuration and communication. This is required so that the connectors become interoperable and exchangeable. And of course, we have other features of gRPC. gRPC is supporting better throughput for high-frequency data, is supporting requests and responses, supporting subscriptions, and also data streams. All these technologies are required to also address the various kinds of communication in the process automation. As you can see, this topic is very complex, and I can even talk about this for hours. But unfortunately, I have to come to the end of my presentation. So to summarize it up, sorry. With the approach of cascaded connectors, you can address and handle the complexity of the bouquet of communication protocols in the process automation on the industrial edge. And it's the enabler for future edge-based OT connectivity. So thanks for your presentation, for your attention and watching my presentation. And if you want to know more about the industrial edge, here you will find the experts on the booth.